Good morning, Gunanda. Now let's go to the first chapter, sets. Okay. Now let me see one by one. Introductions of sets. Next, sets. And their representation. Okay. Now let's see first one, introductions of sets. The concept of set serves as a fundamental part of the present day mathematics. Okay. In nowadays, the concept of sets serves as a fundamental part of the present day mathematics. And also, today this concept is being used in almost every branch of mathematics. Every branch of mathematics. Every branch of mathematics. It's like algebra, number theory, geometry, arithmetic, etc. And so on, like this. Okay. Next, the sets are used to define the concept of relations and functions. Sets are used to define the concepts of relations and functions. Okay. And also the study of geometry, sequences, probability, so on, etc. Okay. And so we have required the knowledge of sets and those study of this, like the study of the sets are used to define the concepts of relations and functions, and also the study of geometry, sequence, probability, and also this in every branch of mathematics also. Okay. Next, who was developed by theory of sets? Who was developed by theory of sets? Who? The German mathematician Georg Cantor in around 1845 to 1980. And also he was first to encounter the sets. And then while working on problems on trigonometric series. Which one? problems on trigonometric series. Okay, this is a short note on history of about GH counter. Okay, now let's see. In this chapter we discuss some basic definitions and operations involving sets. Okay, in this chapter we discuss some basic definitions and operations involving sets. Okay, next topic, sets and their representation. Here we in this study the sets and their representation. Sets and their representation. Okay, in everyday life, that is in real life, okay, we often speak of collections of objects of a particular kind, such as a pack of cards. Okay, and crowd of people. Next, a cricket team. These are all the collections of objects of a particular kind, such as a pack of cards, crowd of people, cricket teams, and so on. Okay, next, what we see, next we see in mathematics also we come across the collections of natural numbers, collections of points, and then collections of prime numbers and collections of integers, collections of rationals, and so on, etc. These are all in mathematics. Collections of natural numbers, points, collections of points, collections of numbers, collections of integers, collections of rationals, and also collections of reals, so on, etc. And more especially, we examine the following collections. Now let's see one by one. First one, hard natural numbers. Less than 10. That is 1, 3, 5, 7, 9. These are all odd natural numbers less than 10. Okay. Next one, the rivers of India. Next, vowels in the English alphabet letters, namely, that is A, E, I, O, U. These are the vowels. Next, various kinds of triangles. Next, 5 part. Prime factors of to 10, namely 2, 3, 5, and 7. These are all prime factors of root 10. Next one finds the solution of the given equation x square minus 5x plus 6 equal to 0. The solution of the given equation, usually x is equal to 2 and 3. These are all the specially we examine the following collections. Okay. Next, finally, we note that each of the above example is a well-defined collection of objects. But we note that each of the above example is a well-defined collection of objects. Okay. Next, Let us come make a decision now. What we decide? We can definitely decide whether a given object, anyone take object, take an example related to this one, rivers of India, the river Nile. Okay, we can definitely decide whether a given object, a given particular object belongs to this one. Andre it makes collections belongs to a collections or not. Okay. That means the river Nile does not belongs to the collections of rivers of India. Understand this one? The river Nile does not belongs to the collections of rivers of India because the river Nile is not located in our country. Okay. Next, another one example. River Ganga. In other hand, the river Ganga does belongs to the collections of rivers of India. Is it right or wrong? Yes, right. This is the collections of rivers of India. Okay. It's especially now see in real life, in space. Okay. Now we give below few more examples of sets used particularly in mathematics. Particularly in mathematics. Examples. Capital N represents set of natural numbers. Next one, capital Z, set of all integers. Next one, set of all rationals. Next one, set of all real. Set of all real numbers. And Q is also set of all rational numbers. And also we have seen some more examples. set of all capital Z plus represents set of all positive integers. Next, Q plus represents set of all positive rationals. Next one, set of all positive reals. Okay. And also see other examples also. Next, finally, we shall say that yes. Now, what is a set? In before see so many examples related to these collections of objects in sets. Okay. If so, what is sets? A set is a collection of well-defined distinct objects. Okay. What is a set? And what is meant by set? A set is a collection of well-defined distinct objects. And how to define a set? Just a set is a collection of objects. Simply we define a set is a collection of objects. But what is the meaning of sets? A set is a collection of well-defined distinct objects. Okay. Now, a set is described by some following few points, and also see small description. Okay. If A is an element of A is an element of a set A. Okay. We say that A belongs to capital A. And also used to Greek symbol. We use Greek symbol. This is Greek symbol. And also read epsilon. This is used to denote the Paris belongs to. Okay. This symbol is used to denote the belongs to. Then we write small letter A belongs to capital letter of B. That is A belongs to A. Okay. Next, if B is not element of set A. Next, if B is not a element of set A, then we write B does not belongs to A. Then we use the symbol. How can we write? It implies B does not belongs to A. Okay. In this, we have to see some elements belongs to a set A. Then we use the symbol epsilon. Then it implies A belongs to A. Okay. If element does not belongs to A, then we write it implies B does not belongs to A. Next, now see one more examples. In the set V of vowels, in the English alphabet, letters, the set V is equal to set of all A, E, I, O, Q. Okay. If A is an element, this element belongs to what? Belongs to in the set of vowels. Belongs to V. But B, where is B? B is not there. So B is does not belongs to V. Okay. Next, another one example. In the set P of prime factors, we know prime numbers 2, 3, 5, 7, 11, 13, 17, and so on. But in this set P of prime factors of 30 only. Now find it. 30 to 15 but 15, 2 is does not divides 15, but it also divides then 7.5. 7.5 is not a prime factors. Okay, next 30 also divides 3. Yes, 3 tens are. Okay, next 30 also divides 5. 5 6th. So if so, 2, 3 and 5, these are all the prime factors of 30 only. Now set P is equal to set of all prime factors of 30 only 2, 3, 5. This is the set of prime factors. Okay. These are all the discuss about the sets and their representation. Now what we see? Now we again notidu what is set and their representation. How to representations of sets. Okay. Next class alli ನಾವು two methods, representation of two methods of a set. ಒಂದು ಸೆಟ್ ಅಲ್ಲಿ two methods ನ ಹೇಗೆ representation ಮಾಡ್ತೀವಿ ಅನ್ನೋದನ್ನ ನೋಡ್ತಾ ಹೋಗ್ತೀವಿ. ಆಮೇಲೆ some more examples ರಿಲೇಟೆಡ್ ಆಗಿ ನೆಕ್ಸ್ಟ್ ಎಕ್ಸರ್ಸೈಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ನ ನೋಡ್ತಾ ಹೋಗೋಣ. ಓಕೆ.